Hi everyone, today we are going to discuss another important topic, that is congenital dyserythropoietic anemia. Okay, yes. So we are done with the CDA type 2 other test. Then this is the very most important test that we will do in CDA, that is electron microscopy. Yes, everyone knows this. By this time you all got this. This is CDA type 1, which is classical Swiss cheese appearance, right? Swiss cheese appearance. Everyone knows this, but I want you guys to know what is this Swiss cheese appearance, in which parameter we are calling, everything we should know. So this is the first normal, how the normal erythroid will look in electron microscopy like this. See, this is the normal, this is the nucleus, okay, and this is the cytoplasm of a erythroid, normal erythroid precursor, okay. So in the nucleus, again, can you see the darker areas and the lighter areas? And this darker areas is nothing but it is heterochromatin. We all know heterochromatin is inactive chromatin, so it will clump, so it looks dark, and these lighter areas are nothing but they are euchromatin, so they are dividing, they are active dividing, so that's why they look pale, right? But this is the CDA type 1 bone marrow erythroid precursor. So can you see the darker areas, they are reduced, right? So what's happening here in CDA type 1, the darker in a heterochromatin is getting lost, okay, and how it is getting lost? There, this darker areas heterochromatin is reduced, first thing, and how it is getting lost? Why that is called Swiss cheese? Because if you see, there are some small dots here, and I zoom this picture, can you see here? This is heterochromatin. Can you see small dots here, right? Can you observe, right? So in the heterochromatin, this heterochromatin will lose in the form of small holes will come, and everything they will finally lost. That's why this is looking like exactly like this, right? Like the Swiss cheese, right? That's why the Swiss cheese appearance is nothing but they are talking about heterochromatin areas, not the entire nucleus, not the euchromatin. It's the heterochromatin areas which shows the Swiss cheese appearance, not the entire. You can think, okay, this may be the whole, this may be the whole, that's Swiss cheese appearance. No, it's the heterochromatin areas where particularly it's showing the Swiss cheese appearance. And one more finding, can you see, can we hear arrow mark is there? Can you see, this is nucleus and this is cytoplasm. What is this? This is the nuclear membrane, right? Nuclear membrane. What's happening to the membrane? Can you see here? The membrane is going inside, right? The membrane is going inside. So there is another most important finding here also. Can you see? The membrane is going inside, here also, here also. So there is invagination and evagination of nuclear membrane. Invagination and evagination of nuclear membrane. Nuclear membrane. So these are the two classical findings in electron microscopy in CDA type 1. So there is Swiss cheese appearance, which component of this nucleus? Heterochromatin, showing the Swiss cheese appearance of the heterochromatin areas. Then the invagination and evagination of the nuclear membrane. These are the two characteristic findings. Then in CDA type 2, everyone knows this, right? So what happening here? There is double membrane. Okay, double membrane. Okay, I zoomed it this one same picture. Can you see the double membrane? Can you see this is one membrane, this is one membrane. Peripheral, this is also known as peripheral cistern or double membrane. Here, what is this membrane? Is this nuclear membrane or cytoplasmic membrane? That is important. Okay, this is the cytoplasmic membrane of erythroid precursors. Okay, it's the cell membrane or cytoplasmic membrane, or I can say cell membrane, not nuclear membrane. Okay, not nuclear membrane. That you should know. Okay, it's not nuclear membrane, it is the cell membrane, cytoplasmic membrane, which shows duplication, which is also known as double membrane or peripheral cisterns. Okay. Then in type 3, in CDA type 3, we know there is a multinucleated cells because there is aberrant cytokinesis, so there will be giant erythroblast. That is okay. What are the other findings? There will be stellate cytoplasmic, intracytoplasmic inclusions. Can you see? These are stellate intracytoplasmic inclusions. That is one thing. And here there will be, can you see, this is the nuclear membrane only. It's what it's forming? It's going inside and it's forming another membrane, right? Going inside another membrane. So this is known as endo-reduplication of nuclear. NM is nuclear membrane. Okay. So here you should not confuse with CDA type 3 and type 1. Type 1, there will be, what's there in type 1? Type 1, there will be invagination and evagination of the nuclear membrane. Just it's invading. It's not going and forming another membrane here. It's just invading, right? Can you see? It's just invading here. Okay, it's just invading, but it's not forming and a membrane inside again. Okay, so you should not confuse with the CDA type 1 and type 3. Okay, type 1 there is only invagination and evagination of nuclear membrane, but in type 3, this nuclear membrane will go inside and forms another membrane, and this results in the intranuclear clefting. Okay, and then there is a typical name is given for this. It looks like in the electron microscopy fingerprint-like appearance. Fingerprint-like appearance. Okay.